Activity sheet number 10, hypothesis concerning the difference of means. Question number 1. The means of two random samples of size 1000 and 2000 are 67.5 and 68 inches respectively. Can the samples be regarded to have been drawn from the same population of ST 2.5 inches? Test at 5% level of significance. So first get all the information we have. N1 is 1000, N2 2000, X bar 1 67.5, X bar 2 68, and standard deviation from the population is 2.5. So population standard deviation is given, is known. Step number 1, mu1 is equals to mu2, which is our null hypothesis. Alternate hypothesis, we also say at H1, mu1 is not equal to mu2. This is a two-tail test. Step number 2, level of significance given as 0.05, which is 1.96. Step number 3, test statistic. Put all the values in this formula and we will get minus 5.17. Step number 4. Since it is two-tail test, so 1.96 to right and minus 1.96 to left, the region in the center is acceptance region. If the value of test statistic falls in this region, we will accept H0. So minus 5.17 is clearly outside the region. Absolute value of Z is more than Z alpha by 2, so we reject H0. Question number 2. The mean produce of weight of sample of 100 fields is 200 pounds per acre with a standard deviation of 10 pounds. Another sample of 150 fields gave the mean of 220 pounds with a standard deviation of 12 pounds. Can the two samples be considered to have been taken from the same population whose standard deviation is 11? Use 5% level of significance. So first collect all the information from the question. N1 100, N2 150, X bar 1 200, X bar 2 220, S1 is 10, S2 is 12, and the standard deviation from the population is 11. So population standard deviation is known. Step number 1, mu1 is equals to mu2. H1 mu1 is not equals to mu2. Step number 2, level of significance is 0.05, which is 1.96, and it is a two-tail test. Step number 3, test statistic. Put all the values here. We'll get minus 14.08. So graphically, it's a two-tail test. 1.96 is here, minus 1.96 on the left side. If the value of test statistic falls in this region, it means H0 is true. Since the value minus 14.08 is outside the region, so we reject H0 as 14.08 is more than 1.96. So maybe they are not from the same population. Number 3, the mean height of 50 male students, N1 is 50, who showed above average participation in college athletics was 68.2. X bar 1 is equal to 68.2. With SD of 2.5, S1 is equal to 2.5. While 50 male students N2 is equal to 50, who showed no interest in such participation, had a mean height of So the mean x bar 2 is equal to 67.5 with the ST of 2.8 inches. S2 is equal to 2.8. Test the hypothesis that male students who participate in college athletics are taller than other male students. Step number 1, H0 mu1 is equal to mu2. H1 mu1 is more than mu2. It is right tail test or one tail test. So we have formulated our hypothesis. Step number 2, level of significance is equal to 0.05, and from table of z distribution we got 1.645. Step number 3, test statistic. Put all the values in this formula and we'll get 1.32. Step number 4, reject H0 if Z is more than Z alpha, or we can refer to the diagram 1.645 to the right here, and the left side is acceptance region. If the value of test statistic falls here, it means H0 is true. 1.32 falls in the acceptance region, so we accept H0. Number 4, the average number of articles produced by two machines per day are 200 and 250, with SD 20 and 25 respectively on the basis of 25 days production. Can you regard both the machines equally efficient at 1% level of significance? N1 is equal to 25, X bar 1 is equal to 200, and S1 is equal to 20. N2 is 25 in 25 days. X bar 2 250 and S2 is equal to 25. First step, formulate the hypothesis that the production is same. H1 the production is different, mu1 is not equal to mu2, and it is two-tailed test. Step number 2, level of significance is 0.01 and equals to 2.58 from the z distribution table. Step number 3, test statistic. Put here all the values. Since we don't have the standard deviation from the population, we'll get minus 7.81. So graphically 2.58, two-tail test, minus 2.58 and plus 2.58. If the value of test statistic falls in this region, we will accept H0. So minus 7.81 is clearly outside this area, so we will reject H0, or reject H0 if absolute value of Z is more than Z alpha by 2, and here 7.81 is more than 2.58, so we reject H0. This is the end of the lesson. Thank you.